today's lesson, section 7.1a, Trigonometric Identities. Here, what we're going to do is we're going to basically be working with all the identities that we kind of worked with and some new ones, and then work with verifying whether two sides of an equation are equal to one another. So we need to kind of restate things that we've already talked about. So here you have the reciprocal identities for cosecant, secant, and cotangent. If you don't have these written down from before, you might want them now because we're really going to use them heavily. Especially the Pythagorean identities. We haven't used them in prior chapters as much, but this chapter we'll use these identities, especially sine squared plus cosine squared equals 1. That'll be an identity that we come across a lot. Also, it's good to know the even and odd identities. Remember that sine and tangent are odd, and cosine's even. So that's why cosine's a little different than the sine and tangent ones. You also have the cofunction identities. Now, these ones mean that if you take, like let's say sine, and it's like pi over 2, so 90 degrees, minus a angle, that's the same thing as figuring out the cosine of that angle. Remember that in a right triangle for sine and cosine, if you're looking at from one angle, looking at a ratio for sine, from the opposite angle, so the complement of the angle from the opposite corner, not the right angle, but the opposite corner. So let me draw a picture here so I can describe this for you. So if you say this is theta, and let's say this is u over here, okay? Theta and u are complements with one another. They add up to 90 degrees. So if I find the sine of theta, that's the same thing as looking at the cosine from the other angle, because let's say you have A, B, C. Let's do that. So in this case, sine of theta would be A over C. So if I did cosine of u, then that's the adjacent side, so it's also A over C. So they match each other. So that's what cofunctions are trying to tell you, is that the opposite angle of a right triangle is the same thing as the cosine, or the kind of the cofunction of that angle. So sine and cosine go together like that. Tangent and cotangent go together, and secant and cosecant go together. Those will be make more sense because if you go back to our graphing from chapter 5, tangent and cotangent look very similar. They're just a relationship of shifting over a little bit, and there's also a flip there too. Secant and cosecant are very similar to each other as well, based on the pictures. So those are some identities that we'll use. But for this section, like I said, we're verifying equations. So using our identities or our problem-solving skills to help us show one side is the same as the other. Now for these, it doesn't matter which side you use it for. Now some sides, like I usually simplify the left side of my equation to show that it's the same as the right. But sometimes it makes more sense to simplify the right side to show that it's the left, or even to use both sides to simplify them in a different way to get them to look like each other. Okay? So here, let's say that I simplify the left side first. So on the left side, I want to change it so that it looks like sine squared theta, and once they match, I can say that I verified it. I showed that they're equal to one another. Okay, because obviously right now it doesn't really look like they're equal to each other. You're just assuming they are. Okay, so here I see that cosine of theta is being multiplied to parentheses. So one thing I like to do is get rid of parentheses. So distribute through. So cosine theta times secant theta minus cosine times cosine is cosine squared theta equals sine squared theta. Okay. Now, one thing, remember if you go back to your reciprocals, secant is the same thing as 1 over cosine. So let's insert 1 over cosine in for secant. See if we can simplify it at all. Now here it looks like cosine over 1 times 1 over cosine. They actually cancel each other out, so you're left with 1. Okay. Now, one of the other properties that is nice to know, like I was saying, is the Pythagorean Theorem, 1 for sine squared plus cosine squared equals 1. So if I, let's say, write that over here, and I'll use the same angles that I've got. Okay, so let's say I maneuver stuff around so I can get sine squared by itself. Well, I would subtract cosine squared to both sides. Okay, so that gives me sine squared equals 1 minus cosine squared theta. Okay, now notice 1 minus cosine squared is over there on the left, so I could replace that with sine squared. So sine squared theta equals sine squared theta. Okay, so now I have proven it. So I always end a proof or verification with a check mark showing that I'm done. Okay, because you don't really box the answer. You can box it if you want, but I usually use a check mark for that. Okay. Now the next one, you have 2 tangent of x secant of x equals 1 over 1 minus sine of x minus 1 over 1 plus sine of x. Now here, it might make more sense to deal with the right side. It looks a little bit more complicated. It looks like it could be simplified. So, now trying to figure out, I want to get these two things to somehow get rid of the minus sign so they multiply, and gives you tangent and secant, obviously. So one thing I like to do is try to put fractions together. So to do that, I need to make common denominators. So the left side, to be a common denominator, needs a 1 plus sine x. Now remember, just because they have sine x and a 1 in common doesn't mean they're the same. They're binomials, so that means that they're completely different. So I need to multiply by the entire thing. Same thing over here. I need 1 minus sine x to both top and bottom. Okay? So it gives you 2 tangent of x, secant of x. So then we get 1 fraction with the denominator. Now if you multiply this out, remember on the bottom you get 1 minus sine of x plus sine of x minus sine x squared x. And on the top, you're just distributing. Now remember, this is would be a negative 1 there. So you get 1 plus sine of x, and then minus 1 plus sine of x. Okay? So then notice that negative sine of x and sine of x on the bottom cancel each other out, and a 1 and a negative 1 cancel each other out in the numerator. So 2 tangent x secant x equals, it'll be 2 sine of x over 1 minus sine of x squared. Now remember, that looks familiar with your sine squared and a minus 1. If you go back, sine squared plus cosine squared equals 1, I can subtract my sine of x squared over. Okay? And so that gives you cosine squared of x equals 1 minus sine squared of x. Okay? And so now you can insert cosine in for that. So then 2 sine of x over cosine squared of x. Now, notice that you need tangent and secant from this point, okay? So you kind of want to separate these out so that you can get two separate things. So for for tangent, you need sine over cosine. So it would be helpful if you maneuvered stuff around as a fraction so that you get separated, because it's all multiplication, because cosine squared is the same thing as cosine times cosine. So I can separate them by multiplication, plus for secant, you need 1 over cosine. So now that you have that, now you can simplify. And you get your answer, okay? So the next video we'll be working on kind of the same thing, okay? Have fun.